Good evening, everyone. I am Kyla Basco as your next reporter, and we were going to start with two Asian folks to discuss about pre-Columbian Americans. First and foremost, the Mayans are a diversified set of Central American indigenous peoples. They are well known for their infrastructure, which includes limestone pyramids. It is a calcium carbonate sedimentary rock that is commonly utilized in the manufacture of cement by heating powdered limestone with clay. In addition, the House of Mayan is shaped like an oval and has similar dimensions. Because Mayans spend time during the day hunting, farming, and cooking, their house only contains one room, which they believe is for relaxing, sleeping, and storing limited personal goods. The house's roof is made of thatch called palapa, which can last 3 to 4 years before needing to be replaced. Whereas palm roofs can endure anywhere from 8 to 20 years. Cacao beans are used as a monetary unit in the Mayan economy for the exchange of commodities and services. The Mayans of Central America inherited the all-mixed cacao expertise, which they respected as well as consumed. Mayans consider cacao beans to be a gift from God, hence they are extremely valued. The Mayans also had huge sculpture ready for a significant event, which they used for Mayan ceremonies, warfare, and even human sacrifice. The stela, a big, tall stone slab with carvings and writing on it, was the most popular sculpture. Stelas were quite popular throughout the classic Maya period, and they were created in honor of their kings and placed near the altar in most large cities. The ancient Maya were keen astronomers who meticulously recorded and interpreted all aspects of the sky. They created the bigesimal numerical system. In this system, only 3 symbols were required to write numbers down. A horizontal bar denoted the number 5, a dot denoted the number 1, and the circular symbol, possibly a shell, denoted 0 as a placeholder. Unlike our current system, which starts on the right and works its way to the left. Apart from numbers, the Mayans created calendars which were employed by Mesoamericans as well. It was based on a 260-day called as Tzolk'in and a 365-day called as Ab, which is comparable to our current calendar, which has 18 months of 20 days each. The Aztecs were a Mesoamerican culture that flourished in central Mexico during the post-classical period after Mayan civilization. Aztec temples were more than just structures dedicated to prayer, especially to their gods, in terms of infrastructure. But the Aztecs adored the god of the sun and war above all other gods. Meanwhile, the Aztecs utilized a bigesimal system in astronomy, similar to the Mayan number system rather than our decimal system. They also painted the Codex Vergara, which comprises schematic drawings and field measurements. Also, previous research has demonstrated that they understand multiplication, division, and even some basic principles of geometry where they involve simply multiplying length by width. Additionally, the Aztec calendar dating system is based on the Mayan calendar, which is currently on display at the National Museum of Anthropology in Mexico City. The Aztecs were also famous for their agriculture because of their brilliant chinampa system of having floating gardens where 3 crops were farmed, the staples of the Aztec diet such as corn, beans, and squash, each of which assisted the other when they were grown together. So these are called the 3 sisters. Aside from that, they also grew various vegetables such as avocados, chili peppers, and tomatoes, and sometimes flowers. Yet, when it comes to clothes, the Aztecs passed a law that forbade poor people from wearing cotton, and among the Incans, only the rich people or rich Aztecs could wear a special women's cloth called kumbi, a fine soft cloth often made of baby alpaca wool that was valued as highly as gold. Similarly, the clothes of the poorest members of society were quite plain. After the free Columbian Americans period, we also have scientific revolution. This era refers to major scientific advances that lead to a significant shifts in scientific inquiry. The universe model is an important contribution to this scientific revolution. The universe model is developed by Nicolaus Copernicus, published in 1543. The model represented the Sun at the center of the universe, motionless with Earth and the other planets such as Mercury, Venus, Mars, Jupiter, Saturn, and also the Moon and the fixed stars. After that, we have law of planetary motion, which also developed by German astronomer Johannes Kepler. In his theory, the path of the planets about the Sun is elliptical in shape or in an oval-shaped path with the center of the Sun being located at one focus or called as foci. So, even other bodies in the solar system is farther away from the Sun, they are still have elliptical orbits. The second law helps to establish that when a planet is closer to the Sun, it means it travels faster. While the third law expresses that the farther a planet is from the Sun, the slower its orbital speed. Next, we have Work of Motion by Galileo Galilei as the founder of modern physics and laid down the first accurate law of motion for masses. Galileo measured that all bodies accelerate at the same rate regardless of their size or mass. It involves the concept of motion in terms of velocity like speed and direction, development the idea of force as cause per motion, the idea in which the natural state of an object is rest or uniform motion, and the law of inertia, as he used it to explain how it's possible that if Earth is really spinning on its axis and orbiting the Sun. Besides of inertia, consider as Newton's first law of motion. He states that if a body is at rest or keep moving in a straight line at a constant speed, unless it was acted upon by a force as a uniform motion. Newton's second law of motion says that acceleration or gaining speed happens when a force acts on a mass of an object. It also says that the greater mass of the object, the smaller the change produced by an applied force. Next, we have Newton's third law of motion, also known as the law of action and reaction, because it states that for every action or force in nature, there is an equal and opposite reactions. If object A exerts a force on object B also exerts an equal and opposite force on object A. In other words, forces results from interactions. Lastly, we have law of universal gravitation. It states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction.